Hello everyone. How are you all? How about your studies? All good? All good, guys? Do reply in the chat box. Okay. I hope you all studies, everything is all good. So, guys, once again, a very warm welcome to your very own channel. Let's crack NEET UG in English. Myself, Sharada Alok. I have been teaching chemistry at Resonance from past 10 years. How you can get connected to us? Let me tell you. Guys, first of all, what you have to do? Just a second. Yes, guys, how you can get connected to us? First of all, what you have to do? Come on, let me tell you. First of all, go to Play Store, then download the Unacademy Learning app. Okay, and then click on to NEET UG. Is that clear, guys? Then click on to subscription. Okay, but before you go ahead for the subscription, let me tell you the benefit of taking plus subscription. Guys, you'll be taught by the top educators across the nation. I'm repeating, you'll be taught by the top educators across the nation, where you can chat with your educator in the daily live classes, engage in discussion, you can ask all your doubts, answer the poll, all while the class is going on. Not only that, you'll be getting live test and quizzes which is going to evaluate your preparation with a regular mock test. Okay, guys, what are the benefit of giving this quizzes? First of all, it is going to minimize your negative marking. It is going to sharpen your IQ. It is going to evaluate your preparation. It is going to add a lot of confidence to the confidence quotient and by giving your every best in the quizzes, guys, by giving your every best, what you will happen? What will happen by giving your every best? Yes, you will win the referral code out of which you can buy any of the courses running at an academy. Not only that, you'll be getting a structured course. All our courses are structured in line with the exam syllabus, which is going to help you to best prepare for it. Okay, guys, not only that, just by getting one subscription, you get access to all our live and recorded courses which you can watch from the comfort of any of your devices. Okay, guys, this has been recently launched by an academy iconic subscription, which is going to take your NEET UG preparation to the next level with personal coach. Okay, guys, the top educators are going to be your personal coach. You get one on one guidance from the top exam expert as your personal coach to align your preparation strategy. Not only that, you'll be getting an in depth test analysis with personalized feedback, which is definitely going to improve your time management and exam approach. You'll be getting a study planner that is going to ace your preparation with customized study plan. You're going to get a bi-weekly reviews that is going to highlight your progress. So guys, just by getting one iconic subscription, you get daily live classes from top educators. Not only that, you get mock test and quizzes. You get structured batch course very much in line with the exam syllabus. Guys, whether to go for plus subscription or the iconic one, let me tell you guys, let me tell you. Whatever you are going to get under plus subscription, you'll be getting the same under iconic subscription. But these are the iconic features, whether you talk about personal coach, study planner, expert guidelines, or in-depth test analysis. Guys, how much you have to pay if you want to go for iconic subscription? Let me tell you. For 6 months, you are supposed to pay 38,000. That is going to cost only 6,333 rupees. For 1 year, you will have to pay 65,000, which is going to cost you only 5,417 per month. For 2 years, you are supposed to pay 1 lakh. That is going to cost you 4,167 rupees only. And don't forget to apply this referral code of mine SA10, guys. And after applying the referral code, I mean SA10, you will be getting the same subscription at the cost of, for example, for 6 months you are supposed to pay only 34,200. Yes, yes, yes. Once you apply this referral code of mine, you'll have to pay this amount, 34,200 for 6 months, and for 1 year you are supposed to pay 58,500. For 2 years you'll have to pay 90,000. Guys, that is going to cost you around 3,750 rupees only per month. Guys, these 6 months, 12 months and 24 months are available at no cost EMI. Okay guys, don't forget to apply this referral code of mine, SA10. Now guys, how much you have to pay for plus subscription, let me tell you. Right from 1 month, 3 months, 6 months, 12 months, and 24 months subscription are there on the screen. Okay, guys, for 1 year, you will have to pay 38,500. That is going to cost you 3,208 rupees only. Guys, I would recommend you that there is no point in going for 1 month, 3 month, or 6 month now. Why? These are good as long as you're planning for the crash course, guys. Okay, because you have a lot of time, and I would recommend you personally that there is no point in going for them now. Okay, so if you are in class 12 or a dropper student, you must go for this 1 year subscription by paying 208 rupees per month. That is going to cost you altogether for 1 year 38,500. And if you are in class 11, I would recommend you that you should pay 56,000 for 2 years. But again, as I told you before, if you apply this referral code of mine, SA10, you will have to pay only, guys, for 1 year. You are supposed to pay only 34,650 rupees. That is going to cost you 2,888 rupees only. For 2 years subscription, you'll have to pay 50,400. That is going to come around cost you 2,100 only per month. So I would recommend you personally, if you are a class 11 student, you must go for this 2 years subscription by paying 50,400. And if you are a dropper or a class 12 student, you must pay 34,650 rupees, which is going to cost you 2,888 only. But don't forget to apply this referral code of mine, SA10, guys. And all these are available at no cost EMI. Don't forget that. Okay, guys, now let us discuss for which we are gathered here. Yes, let us discuss the questions of chemical equilibrium, guys. You can see chemical equilibrium. We have already discussed chemical equilibrium. Now we are going to discuss NCERT based questions. Are you all guys ready? Yes, all those who are ready, do one thing, get get ready. Ensure yourself that you are not getting disturbed by anything around you. Secondly, take a pen and copy in your hand. And yes, the most important one, all your eyes on the screen only. And yes, before that, all those who are watching, do share to all your friends who are preparing for NEET 2021, 2022, or for board examination, or preparing for improvement, or they who are in J mains or advanced. You can share them too. Okay, guys. Okay, I hope all your eyes on the screen now, and all those who are watching this channel, let's crack NEET TUJ in English for the first time. Do subscribe the channel if you have not done so, and do press the bell icon as well if you have not done so. So guys, let us start with the first question. I hope all this which is there being shown on the screen is known to you. For example, at equilibrium, rate of forward reaction and rate of backward reaction at equilibrium is equal. Okay, guys. Okay, is that clear? pH of water, like negative pH of an acidic solution, is given by negative log of H plus sign, where H plus ion, the concentration given in mole per liter. pH of water at 25 degrees centigrade is given as pH negative log of H plus, and at 25 degrees centigrade, only 10 raised to the power minus 7 moles of water are ionized. Therefore, the pH of water at 25 degrees centigrade is neutral, that is 7. If acidic pH is there, then pH has to be less than 7. For basic pH, it has to be more than 7. For neutral, as it is just now discussed, it should be 7 only. Ionic product of water is product of concentration of hydronium ion and that of hydroxide ion, which is given by 10 raised to the power minus 14. And pKw, the negative log of Kw will be given by negative log of H plus and negative log of H minus, which is coming around pH plus pOH equals to 14. Is that clear, guys? Now the very first question on the screen. All your eyes on the screen, guys. All your eyes on the screen. Ensure yourself that you are not getting disturbed by anything. Take a pen and copy in your hand. Guys, the very first question is, a liquid is in equilibrium with its vapor. Let me take a white pen here. A liquid is in equilibrium with its vapor in a sealed container at a fixed temperature. Always remember, as I keep telling you, that whenever you are going to solve any questions, try to make a rough diagram of it, mentioning all the things given in the question. A liquid is in equilibrium with its vapor. This is the liquid, of course, it will be present over here in the container, and it is in equilibrium with its vapor. These are the vapor. This is the symbol of equilibrium between the liquid and its vapor. It is fixed, sealed in a fixed temperature, all at a fixed temperature. The volume of the container is suddenly increased. Guys, suppose whatever the volume, it is certainly increased. What is going to happen? Okay, the first one is, first question under this is, what will be the final vapor pressure? What will be the final vapor pressure and what will happen when equilibrium is restored finally? Very, very important question. And the answer is given in the question itself. Guys, the equilibrium with its vapor in a sealed container at a fixed temperature. Okay, all is given at a fixed temperature, isn't it? Only the volume is suddenly increased. Okay, guys. So the answer of the first one will be, initially the vapor pressure will decrease because the same amount of vapor are now distributed in larger space. Initially, remember, initially, because these vapors these vapors are, suppose whatever the volume might be V, here the volume might be 2V, for example. Okay, so now the same vapor has to occupy this entire space over the liquid. Are you getting this? This is the liquid, suppose. So, initial effect, it has been asked what will be the final pressure and what will be when equilibrium restored finally. Okay, guys. Okay. So, initially, what is going to happen? Remember, initially, the pressure, vapor pressure, guys. Initially, the vapor pressure will decrease. Why it will decrease? Because the same vapor has to occupy a larger volume. Okay, guys. Now the question is actually what will be the final vapor pressure and what will happen when equilibrium is restored finally. So initially it is done. Now let us see what will happen now. Okay, guys. Okay, the rate of evaporations remain constant. Remain. Why the rate of evaporation will be constant? Do you have any idea? I told you the question, the answer is given in the question itself. At a fixed temperature. Okay, guys, because there is no temperature change, therefore the rate of evaporation remains constant at a constant temperature. Okay, guys, is that clear? In a closed vessel, because guys, because vapor pressure is actually an equilibrium constant. For example, H2O liquid. Okay, just take an example of water. H2O liquid gets vaporizes H2O gas. Okay, Okay, guys, this is called as it is in equilibrium. This temperature is called as boiling point. All done. At this, the equilibrium constant is written as pH2O. Why? Because H2O liquid or solid, pure liquid and solid, it is taken as one. Okay, guys. So Kp is actually vapor pressure of water. So as long as the temperature is constant, the Kp, actually the vapor pressure of the liquid is actually the equilibrium constant. And we all know that equilibrium constant changes only with the change in temperature. Is that clear, guys? Equilibrium constant changes only with the change in temperature. Therefore, rate of evaporation remains constant. I hope it is clear, guys. The rate of evaporation remains constant. All done? All done, guys. Now, guys, the rate of condensation will be low initially. Okay, why the rate of condensation? See, if you talk about this reaction, the forward is what? Evaporation, and the backward is condensation. Here the forward reaction is evaporation and backward is condensation. Let me take an eraser. The backward is condensation here, guys. Is that clear? The backward is condensation. Let me take. Okay, all clear now. Now let us see what is happening. Guys, the rate of condensation initially will be what? Initially it will be low. Yes, initially the rate of condensation will be low. All clear now. Okay, guys, sorry, there was a fluctuation in the net, I think. I'm sorry. Okay, guys, now let us go ahead. Yes, guys. All those who are watching, do like the video. If you have not done so, do share the link of the video to all your near and dear ones. Okay, guys. Okay. Now, guys, now, yeah. So let us look back at the screen. I'm so sorry for the fluctuation you had to face. Problem, whatever. Sorry, guys. Now, like, look back at the screen. Okay, it's all fine now. Yeah. So just have a look here, guys. Just have a look. Yep. What is happening? Initially, the rate of condensation will be low initially because there are fewer molecule per unit volume. Again, because the volume is increased, so few molecule per unit volume. Okay, guys, is that clear? In the vapor phase, hence number of collision. Suppose this is a molecule, this is the molecule. So number of collision initially will be low initially because these molecules are spreaded over a large volume. The same molecule which were spreaded in a V volume are spreaded in a 2V volume. Because of that, what is going to happen? The rate of condensation will be low because when the molecule get collided, when they collide each other, they undergo condensation. As the collision is less, okay, therefore rate of condensation is also less. Is that clear, guys? Is that clear? Hence number of collision per unit time with the liquid surface decreases. Is that clear? Number of collision per unit time, okay, is decreases. So guys, is all clear now? What is how? See, first of all, write down how initially the rate of evaporation and condensation got changed. We had discussed that. Okay, guys, all done now. Now just have a look. When equilibrium is restored, what is going to happen when the equilibrium, because initially it will take some time. As soon as the same mixture, same vapor is transferred into a larger volume container, it will take some time for the equilibrium to restore, isn't it? And once it is restored, what is going to happen? Simple. Rate of evaporation is going to be equal to rate of condensation. Is that clear? Rate of evaporation is going to be equal to rate of condensation. I hope it is clear. Very good afternoon, Ritik. How are you, dear? Very good afternoon. Okay. So, guys, once the equilibrium is restored, rate of evaporation becomes equal to rate of condensation. What is going to happen to the final pressure? The final pressure will be same. I told you the final pressure will be same because it was originally vapor pressure of liquid. It was, we have already discussed that vapor pressure of the liquid is what? Vapor pressure of the liquid is what, guys? Do let me know. Vapor pressure of the liquid is actually the equilibrium constant. Just now we have discussed it. Is that clear, everything? So write down the effect observed when there was a change in vapor pressure. Okay, when there was a change in vapor pressure, it all is going to happen initially, guys, because vapor pressure is an equilibrium constant. So once the equilibrium is restored, there won't be any change, guys. I hope it is all clear. Is this clear? So always remember, guys, always remember that vapor pressure is actually the equilibrium constant, and it is going to change change in only with the change in temperature. All done? Let us go ahead. Let us go ahead. What is Kc for the following equilibrium? Kc for the following equilibrium when the equilibrium concentration of each substance is, guys, SO2, O2 and SO3 concentration is given. Now following equilibrium reaction, what will be the reaction? It is a very common, well known reaction. Ritik, how about your studies, dear? All good? Well done. So guys, have a look at the screen. What is the reaction? We all know that contact process. This reaction is famous, widely used in contact process, guys, where sulfur dioxide, I'm repeating, sulfur dioxide is reacted with oxygen, get oxidized to SO3. Guys, this is the balanced equation. Any problem with that? This is a major reaction widely used in contact process where SO3 is produced by oxidation of sulfur dioxide. Clear, guys? Now, how this Kc is actually calculated? It is calculated by the molar concentration of SO3. And remember, guys, these are the stoichiometric ratio of the balanced reaction. 2 moles of SO2 will combine with 1 mole of oxygen, will give 2 moles of SO3. So these stoichiometric ratio, you just keep a power of it. SO3 raised to the power 2 will be, is it okay, guys? It will be SO3 raised to the power 2 upon SO2 raised to the power 2, because 2 moles are there. So this power will be the stoichiometric ratio over here. Then it will be O2 raised to the power 1. Is that clear, guys? Now just put on the values given in the question and solve it, isn't it? So the concentration of SO3 is how much? Guys, SO3 concentration is just given as 1.90. So just put 1.90 over here, square of that. How much SO2 is there? 0.60, square of that. Oxygen is 0.82. Is that clear? And then simply solve it, guys. Simply solve it. How much you are going to get? 12.2. Is that clear? Is that clear, guys? 12.2. All done. And what will be the unit? Let us find out the unit. Guys, this is mole per liter. Mole per liter. This is also mole per liter. Now, mole per liter square and mole per liter square of these two are going to get cancelled. Only you are left with mole per liter of oxygen. And as it is 1 upon mole per liter, so the unit is going to be mole, not per liter, but per mole liter. Is that clear? Is that clear, guys? Mole per liter. Remember, Kc, the unit will be 1 upon mole per liter. So it will be go up and it will become mole inverse and liter. Why? Because mole per liter and mole per liter, both of SO3 and SO2 are being squared, which is going to get cancelled. So you are left with only the concentration of oxygen as mole per liter. So it will become inverse of that. I hope it is straight away going here. Clear? Guys, you have to be very, very particular for the unit when delta Ng, I'm repeating, when delta Ng is not equal to 0. Okay, you have to be particular about the unit. Remember, when delta Ng is 0, it is going to be unitless. Is that clear? Is that clear? Why? Because it will get cancelled. Okay, guys. Okay. So unit has to be what? You can say delta Ng. Unit of Kc should be unit of Kc. It should be mole per liter raised to the power delta Ng when you are taking the concentration in mole per liter. If you are taking the concentration in atm, that partial pressure, we take the Kp calculation. In that, we are supposed to take the pressure. Here we have taken the concentration, but for gaseous generally we use to calculate Kp, and unit of Kp is going to be simply atm, because we are supposed to take the partial pressure, and the unit for that taken is atm generally will be delta Ng. Atm raised to the power delta Ng. Or if any other unit is there, you write down that unit, suppose millimeter, torr, whatever, then it is going to be the unit of that raised to the power delta Ng. I hope how to take the unit is very, very clear to you. All those who are watching, I would like to tell you, if you have not liked the video, do so. If you have not subscribed the channel, those who are watching it either for the first time or not subscribed by for any reason, do subscribe the channel. Let's start NEET UG in English. And one more thing, don't forget to press the bell icon too if you are willing to have all the videos notification without any delay, or you can say without any failure. If you really want to watch all our video, do press the bell icon. And all those who have not shared the video to all their friends who are preparing for NEET 2021 2022, do so that they also will able to take full help out of this. They're able to accelerate their preparation for NEET 2021, guys. Now, guys, the next question on the screen: at a certain temperature and total pressure of 10 raised to the power 5 Pascal. I'm sorry, this is not 100 0. This is 10 raised to the power 5 Pascal. Iodine vapor contains 40% by volume of iodine. Okay, at a certain temperature, total pressure is given, guys. Calculate Kp for the equilibrium. Let us write down the reaction. The reaction is already written over here, guys. Iodine vapor will be shown this way. At room temperature, we all know that iodine exists in solid state. It is very much in equilibrium with its vapor, like that. Okay, is that clear, guys? Is that clear? Iodine gas, it is in equilibrium with its vapor. All done. Now the total pressure is given, guys. Now what is the partial pressure? Can you tell me, guys? Partial pressure is equal to mole fraction into P total. Partial pressure is equal to mole fraction into P total. Is that clear? Partial pressure is equal to mole fraction into P total. Now 40% by volume of iodine is there. Is that clear? 40%. Let the total volume, guys, maybe 100. Okay. 40% volume is occupied by iodine atom. So volume of iodine atom is 40, whereas that of I2 molecule is 60. How to find out the moles? We know that moles can be found out with respect to volume as well. How come? Occupied volume by total volume. Is that clear? Is that clear, guys? So guys, the mole fraction of I will be partial pressure of I atom is going to be mole fraction. It will be 40 upon 60 into guys total pressure, which is given as 10 raised to the power 5 Pascal. I hope it is very, very clear, guys. So how much it is going to be? It is going to be zero point 0.4, or you can say 4 into 10 raised to the power 4 Pascal. Is that clear, guys? Is that clear? Okay, okay, guys. I hope it is all straight away going here. Moles, total moles we have considered as, because 40% by volume. So given volume by total volume will give you the moles. Okay, okay, guys. All done. Now, partial pressure of I2 will be same, 60 upon 100 into 10 raised to the power 5, which is going to be how much? Which is going to be how much, guys? It is going to be 6 into 10 raised to the power 4 Pascal. Now, Kp is to be calculated, guys. Kp is to be calculated for, I just now told you, for gaseous one, we take the pressure. So, pressure of I will be raised to the power stoichiometric ratio. It is 2. So, pressure of I atom raised to the power 2 upon pressure of I2 raised to the power 1, because here it is 1. So, pressure of I atom raised to the power 2. How much pressure is calculated here? It is calculated here as 4 into 10 raised to the power 4 square upon 6 into 10 raised to the power 4. Is that clear? This, on solving, you get a value 2.67 into 10 raised to the power 4 Pascal. That's it. Is that clear, guys? Is that clear? Come on, is that clear? So this is a very, very important question, guys. We always should be ready with the formula and how to apply the formula. For example, you have been calculating mole fraction as given moles of a particular species by total moles. Okay, here in the composition only I2 and iodine are there. Only these two are gaseous component. So mole fraction of any one is going to be moles of it upon total moles. Now here moles were not given. What is given? Volume is given. And as we know, guys, moles are going to be directly proportional to, like, if moles are there, if volume are also there, can we calculate the moles? Yes, given volume by 22400. That way we find out the moles. And here what was given? 40% by volume. So how, whatever the molar ratio is going to be directly proportional to the volume ratio as well. Is that clear? So you should also be ready how to apply the particular formula. Okay, okay, guys, done. Let us go ahead. Now, write the expression for the equilibrium constant Kc for each of the following reaction. It is very, very simple, guys. 2 moles of 2 moles of nitrile chloride is giving nitric oxide, that is getting decomposed into nitric oxide and Cl2. So it is very, very simple, guys. The equilibrium constant Kc for this will be written as equal to the concentration, guys, concentration, active concentration, okay, of NO. Is that clear? In the square bracket, if you're writing it down, that means you are taking the concentration in terms of mole per liter. Is that clear? So NO is in gaseous state, guys. We NO raised to the power 2 as 2 moles of NaCl on decomposition in equilibrium, giving 2 moles of nitric oxide and 1 mole of chlorine. Is that clear? So it will be what, guys? Equal to the multiplied by the concentration of Cl2 raised to the power 1, because stoichiometric ratio is 1. I hope you guys are getting it properly. All those who are watching it, do like the video. If you have not done so, do share the video if you have not done so, and do subscribe the channel if you have not done so. Do press the bell icon too if you have not done so. Upon the reactant, now the reactant is NOCl, again raised to the power 2. The stoichiometric ratio has to be there, isn't it? Stoichiometric ratio, balanced equation, the total moles. What are the stoichiometric ratio, guys? The moles present in a balanced equation. That's it. 2 moles of NaCl on decomposition gives 2 moles of NO and 1 mole of Cl2. So the concentration raised to the power 2 into concentration of chlorine raised to the power 1 upon concentration of NaCl raised to the power 2. Is that clear? Okay, all done, guys. Now Kc. In this equation, again, what we have to do, take Kc is equal to, guys, whatever the mole, I mean species present in the product will be at the numerator part. For example, it will be CuO raised to the power 2 because 2 moles of copper oxides are forming. Sundari, science, well done. I'm so happy to see your answer in the chat box. First of all, welcome to the class, beta. Welcome to the channel because I think this is your first class, right? I didn't find you before. Well done. Very nice answer. Now, guys, CuO whole square. Then what will be? NO2. Concentration of NO2 raised to the power what? 4 moles in stoichiometric ratio. So it has to be 4. Is that clear? Then moles of oxygen. There is only 1 mole of oxygen, so it has to be only 1. Is that clear? Upon copper nitrate whole square. Is that clear? How much copper nitrate are there stoichiometrically? 2 moles. So it will be raised to the power 2. I hope you are getting it properly. Done. Now, guys, in this case, Kc is equal to acetic acid, concentration of acetic acid. Okay, all done. Then, guys, then take ethanol. Whatever the product species, remember, whatever the product species are there will be written in the numerator with the power of their stoichiometric ratio, or you can say the moles given in balanced equation. Upon, as 1 mole of acetic acid and 1 mole of ethanol are forming, so this raised to the power 1. Upon, guys, upon ethyl acetate, like this. Again, 1 mole of ethyl acetate is there in the balanced equation, so it will be raised to the power of 1. Upon, yes, then water. This is how Kc for this particular reaction will be written. Is that clear properly? Straight away going here. All done. All done, guys. Now, now let us see the fourth one. Let us see the fourth one. Guys, for this, the Kc will be written down as. Again, I told you, first of all, you have to check. Remember, this time the reactions are balanced, but most of the time, it may not be balanced. So, before solving such questions, just look for the reaction, whether they are balanced or not. And when they are not, if they are not balanced, try to do it. Try to balance it first. And most of the time, see, you need not to go for all those bigger steps of redox reaction in order to, balancing all those steps, the big steps of ion electron method. Generally, such type of reaction will be for NEET level. I'm saying you will be like just by multiplying few number, it will be easily get balanced. Such reactions will be given to you because it will not ask for the level is not up to for NEET that first you have to go for all that ion electron method and then you have to write on the Kc value. Okay, but always ensure that the reaction is balanced. And remember, for the level of NEET, it will be very easily balanced but just by trial error method. Then you just go for the value of Kc. Simply product concentration, here the product is ferric hydroxide raised to the power of 1 upon the concentration of ferric ion raised to the power 1 multiplied by the concentration of hydroxide ion raised to the power, how much moles of hydroxide? 3. So raised to the power 3. This way, Kc is going to be written down. I hope it is straight away going here. Come on, guys. Here, this is iodine on reaction with 5 moles of fluorine gives iodine pentafluoride. For this, the Kc will be written as IF5 raised to the power 2 upon I2 raised to the power 1 multiplied by fluorine raised to the power 5. All done? All done, guys. आ रही है बात समझ में? Are you getting it straight away here? Tell me. Tell me, guys. And always remember, guys, for pure liquid or pure solid, the concentration is taken as one. Sundari Science. So nice to have your answers in the chat box. Really very nice of you to answer in the chat box. Sundari, what's your name? Sundari is your name, beta? Are you from South? Do let me know in the chat box. Guys, let us go ahead for the next question. Now the next question, find out the value of Kc for the following equilibria from the value of Kp. Guys, Kp is given and in all such cases is to be calculated out. There is only one famous formula. Yes, you might have done the derivation in this when you have studied the chapter. Kp is equal to KcRT raised to the power delta Ng. Is that clear? Kp is when we take the concentration, I mean when we take partial pressure of the reactants as well as product. Okay, guys. Kc is molar concentration, active mass. Okay, guys. R is universal gas constant and T is the temperature. And delta Ng is what, guys? Delta Ng is moles of product minus moles of reactant. Delta Ng is moles of product minus moles of reactant. Is that clear, guys? Is that clear? Now, guys, find out the value of Kc from the value of Kp. Okay, how to be done? It's very simple. Find out the value of delta Ng for this reaction. Okay, delta Ng. Let us write here. Delta Ng for first reaction will be what? 2 moles of nitric oxide and 1 mole of chlorine is there. So Sundari from Chennai gonna appear for NEET 2021 as fresher, currently in 12th. Oh, so nice to see you, Sundari. All the very best for 2021. Do subscribe the channel. Let's crack NEET UG in English so that, and also press the bell icon here so that you are able to watch all our videos, all our coming videos, and also you get the link of all the previous videos so far. Okay, guys. Okay, Sundari, is that clear, beta? All the very best to you and all those who are watching, guys. All the very best to you for your examination. We are going to rock together. NEET 2021. We are going to rock together. Trust me. So, guys, delta Ng. Yes, for this first equation, 2 moles of nitric oxide and 1 mole of chlorine together, it comes out to be 3 moles. 3 minus 2 moles of nitric oxide, it will become 3 minus 2, that is simply 1. It will become 3 minus 2, that is simply 1. So, delta Ng for this is how much? 1. Is that clear? So it is very simple. Just put on the value. Kc we have to calculate out, which is going to be equal to Kp upon RT raised to the power delta Ng. Now just keep on putting the value. For first equation, the value of Kp given is 1.8 into 10 raised to the power minus 2 upon R is how much? Guys. R is will be taken as you are taking Kp, given as Kp. Okay, guys, remember, very important thing. Kp is given, so, guys, you should consider the value of R in ATM, unit of ATM per ATM, liter per mole per Kelvin. Is that clear? In that case, the value will be 0.0821. I hope you are getting it. I hope you are getting it. And temperature, how much temperature is there, guys? It is already converted to you for you in Kelvin 500. If it is not so, convert it into Kelvin by adding 273 if it is given in degrees centigrade. I hope it is straight away going here. Clear now. Now, guys, the value of this is coming out to be 4.33 into 10 raised to the power minus 4. Now, all those who are watching, do solve the second one and reply in the chat box. If you have not liked the video, do so. If you have not subscribed the channel, do so. If you have not pressed the bell icon, do so. If you have not shared the video, do so. Come on, guys. Now let us look for the second one. Guys, for second one, as calcium oxide, we have to calculate delta Ng first. Calcium oxide is in solid state, so we have to consider only the gaseous moles of product minus gaseous moles of reactant. So in case of product, there is only CO2, 1 mole. So 1, there is no gaseous moles in reactant side, so it will be simply 1. Again, Kc for the second one will be calculated as Kp. To your mind, you have to keep in your mind when you solve such question is the formula itself first. Kp is equal to Kc into RT raised to the power delta Ng, where this delta Ng is gaseous moles of product minus gaseous moles of reactant. All clear? And always remember this gaseous moles of product and gaseous moles of reactant will only be taken. Why? Because pure solid and pure liquid, it is always taken as, yes, the concentration is taken as considered as one. We don't consider them at all. Okay, all that clear, guys. Now, secondly, the value of R. Whenever you are applying this formula, because you have to consider the pressure as well, so we go for this formula. Okay, guys, is that straight away going here? And the value too. And temperature should always be taken in Kelvin, remember. If it is not so, do so. Convert it. If mostly if it is given in degree centigrade, add 273 to that, and mostly it is given in Kelvin. Nothing. You have to simply put the value in the formula. All done. Let us go ahead. Now, guys, now the next question for the following equilibrium. Kc is given, guys, at 1000 Kelvin. This is the reaction. Nitric oxide is reacting with ozone. I'm repeating. Nitric oxide is reacting with ozone. Welcome, Sushmita. Welcome to the class. And giving nitrogen dioxide and O2. So nice to see you all, guys. Yes. Most of the students say, ma'am, like medical student, they have got a fear of physical chemistry. Guys, I just want to tell you, don't fear. In fact, more the practice. You have to simply, learn the theory part. In fact, try to understand the theory part. Watch the video. If you'll simply try to understand it, reading the book of NCERT, trust me, guys, it is not going to help you. Secondly, it will make you sleep soon. Okay, I have taken each and everything word to word from NCERT. I make my theory video on this equilibrium, taking word to word of NCERT and with a very interesting and colorful examples. Watch those. Secondly, when it comes to solve the numerical, try to apply all those formulas soon after the theory is recovered. Soon after the theory is recovered, guys. All done? Then, because if there is a time gap between the theory reading and the numerical practice, trust me, you are going to lose the confidence. Because whenever we are whenever we do the question, and if theory is lacking or the formula do not straight away come to our mind, we feel very lack of confidence, and we feel we lack interest in doing that. Okay, if you really want to understand, if you really want to accelerate your physical chemistry calculation, always do one practice. First of all, try to understand the theory properly. Keep all the formula into your mind. No need to mug up the formula, just simply keep the formula. And the more you apply the formula in the numerical, trust me, those formula are going to be permanently memorized to you. Not only that, it will be straight away click to you at the time of solving the question. And remember, guys, organic, inorganic, mostly the medical student go for that, because botany, zoology, their approach is what, botany हो गया, zoology हो गया, ऑर्गेनिक हो गया, इनऑर्गेनिक भी किसी तरह याद बात कर लेंगे, फिजिकल का एक आधा फॉर्मूला लगा तो लगा, नहीं तो छोड़ देंगे. Guys, that is the biggest mistake we do. In fact, physical chemistry is the decisive portion of chemistry of your rank. Because most of the student either do not prefer to physical chemistry because they find it harder, and they prefer to leave the question at the time of exam also. And that is the point where they lag in the ranking. Don't ever do this. This is quite dangerous for the rank, for the better rank, guys. because these are the decisive, I tell you, physical chemistry is the decisive, you know, I mean, portion of chemistry for if you talk about in terms of the rank. Don't ever do this practice. And how you will get accustomed, how will you become familiar to physical chemistry is try to solve as many questions as possible, but just before that refresh the theory part. Don't need No need to mug up, just refresh. If you are watching the video, do so. But soon after clearing the theory, you should try to solve the numerical. And if you will think that today I will read the theory and tomorrow I will solve the numerical, or day after that, or after 4 or 5 days, that will always lose your confidence. That will always lose your confidence. No need to complete, you no need to study the entire theory altogether. छोटा सा topic पकड़ो, just read a small portion of the theory and just try to do the numerical based on that small portion of the theory that particular day. That's it. That's it. Trust me, you're going to develop a lot of confidence quotient soon. Okay? Don't ignore physical chemistry, guys. It is quite dangerous. Quite dangerous for better ranking. I hope it is straight away gone here. Let us look the question. But I did not find any answer in the chat box. I thought by the time I will cover this, this counseling part, which is really very important to be taken care of. I will expect the answer in the chat box, but I didn't get any. Please solve it even now. You have time. So, guys, let's look back at the screen. Kc is given, temperature is given. Nitric oxide is reacting with ozone and forming nitrogen dioxide and oxygen gas. Both the forward and reverse reaction in the equilibrium are elementary bimolecular reaction. What is Kc for the reverse reaction? What is Kc for the reverse reaction? All done? Let us have a look. Let us have a look, guys. Let us have a look. Let us have a look. Okay. Both the forward and reverse reaction in equilibrium are elementary and molecular. Remember. So how it is to be done? Very, very simple, guys. Very, very simple. Kc for reverse reaction. Suppose for this Kc is given. When the reaction is just reversed, the reaction becomes NO2 gas gives NO2 plus, sorry, let me take an eraser here. It will become NO2 gas plus O2 gas. It is in equilibrium with NO and O3 like that. For this Kc will be written as NO2 O2 upon NO and O3. All done? Clear? Clear, guys? Now, for this particular reaction which is given on the screen, Kc dash will be written as product, nitric oxide, then O3 upon NO2 and O2. Is that clear? Kc will be written this way. All done? All done, guys? NO O3 upon NO2 O2. Now, what is the relationship between this and this? Can you tell me? Suppose this is equation 1 and this is equation 2. They are just inverse. So, can we write down as Kc is equal to Kc, make it Kc dash this way, is equal to 1 upon Kc. Is that clear? So, always remember, guys, when the reaction is reversed, equilibrium constant becomes inverse. Okay, all clear, guys. Now, what is the value of Kc? It is 1 upon 6.3 into 10 raised to the power 14. So Kc dash comes out to be 1.59 into 10 raised to the power minus 15. All clear, guys? All clear? आया समझ में? Done. Have a look at the screen. Explain why solids and pure liquids can be ignored while writing the equilibrium constant expression. Just now we had discussed this, that we always ignore, we consider them as one. Let us see the reason why it is so. Guys, whether you talk about pure solid or you talk about pure liquid, All done. Whether you talk about pure solid or you talk about pure liquid. What happens, guys? Basically, it is going to be what? Number of moles, all done, upon volume in liter, all done. Now, moles can be what? Given mass upon molar mass upon volume, all done. So, it is going to be what? It is going to be what? Mass upon mass upon, yes, mass upon volume. Sundari, solid concentration is always considered to be 1 when writing the KC. Yes, beta, that is the reason I'm going to tell you. So it is going to be mass upon volume, done, upon molar mass. Now, guys, now this mass upon volume is what? This mass upon volume is density. Density upon molar mass. Very, very important thing I'm going to explain you guys. This is density upon molar mass. And we know that as density of a pure liquid. Sundari and all you guys who are watching this, I'm going to tell you the reason. We have been taking this whenever we discuss equilibrium constant. We always say, your teachers always say, this is constant, pure liquid constant, pure solid constant. Why it is considered as constant is going to be explained on the screen. So guys, the concentration is given a number of moles upon volume in liter. Number of moles can be mass upon molar mass upon volume. Now, mass upon volume upon molar mass, this can be written straight away as mass upon volume is what? It is density. Density upon molar mass. All clear? Now, guys, now a density of a pure liquid or pure solid is considered as constant. All clear? Is considered as constant at constant temperature. At constant temperature, and molecular mass तो है ही constant, isn't it? Molecular mass is constant. All done. Molar concentration are constant. All done. Therefore, pure solid and pure liquid, their concentration are taken, considered as one, or they are constant, or they are not changing at all. All clear? All clear, guys? Done. This explanation is very, very important. Okay, so always keep it in mind. This is the reason we do not take their concentration or we consider them as constant. All done. Now, guys, the next question on the screen, the reaction between nitrogen and oxygen is giving nitrous oxide. Okay. A mixture of a solution of this much mole of oxygen and this much mole of nitrogen is placed in 10 liter, okay, reaction vessel and allowed to form nitrous oxide. Okay, guys, laughing gas at a temperature for which Kc is given. Determine the composition of the equilibrium solution. All clear, guys, all clear. Now let us write down the reaction. Guys, initially what is happening? N2 plus O2, all are in gaseous state. Have a look at the screen. Have a look at the screen. Sundari sign. But well done. I'm so happy that you are interacting, giving your answers, giving your, concepts, everything in the chat box. So nice, beta. So 2 moles of nitrogen is combining with oxygen in the balanced equation, giving 2 moles of nitrous oxide. Okay, guys. Now, what is happening initially when time is 0? Okay, guys, we have taken 0.482 moles of nitrogen and 0.933 moles of oxygen. All clear, guys? What is going to happen at equilibrium? Suppose at equilibrium X mole of nitrogen, okay, is reacting with oxygen. Guys, in the balanced equation, 2 moles of nitrogen are reacting with 1 mole of oxygen. So if X mole of nitrogen will react, it will react with X by 2 moles of oxygen. So how much mole of oxygen will remain left at equilibrium? This much was given, and X by 2 moles of it is reacting. So the left mole of oxygen at equilibrium will be the given mole, initially 0.933, minus the reacted mole of oxygen, and that is X upon 2. I hope it is getting straight away here. And guys, 2 moles of nitrogen are forming 2 moles of nitrous oxide. So X mole of nitrogen will form X mole of nitrous oxide. Is that clear? All clear, guys? All clear? जा रहा है सीधा? Done. Done, guys, now let us calculate the molar concentration, because we are supposed to put the molar concentration in the formula. All clear, guys? Now, molar concentration will be what? Concentration will be what, guys? Concentration will be moles upon volume. All clear? The volume is 10 liter. Therefore, it will be the given molar concentration of nitrogen will be given moles, or the left mole, 0.482 minus X upon 10. That of oxygen is 0.933 minus X upon 2 upon 10. All clear? Now this nitrous oxide will be X upon 10. All clear? Straight away going here. Clear? Clear, guys? Now it is very simple. Find out the value of क्या x निकल गया तो equilibrium composition भी निकल जाएगा, because Kc is given. Okay, guys. Now let us put them all in the formula. Kc will be equal to, guys, N2O raised to the power, yes, stoichiometric moles ratio 2, so it will be 2 upon, guys, N2 concentration raised to the power 2, because 2 moles of N2 into O2. O2 raised to the power 1, because here it is 1. All done. Now simply put on the value. Kc, how much it is given? Kc is given as 2 into 10 raised to the power minus 37, which will be equal to the concentration of N2O. And N2O is given as x upon 10 square upon N2 is how much? Point how much? It is 0.482 upon, yes, minus X upon 10. All clear, guys? All clear? But always remember, guys, remember, yes, take the value, point. Let me take an eraser over here. Those who have solved this, please reply the answer in the chat box. It will be what, guys? It will be 0.482 minus X upon 10 multiplied, yes, square, because 2 moles square is there, multiplied by the concentration of O2, which is 0.933 minus X upon 10. Guys, this is not very difficult. I know this figure. This figure of nitrogen and oxygen might be what? You see, might be just very difficult. यही तो मिस्ट्री है फिजिकल केमिस्ट्री की, बहुत इंटरेस्टिंग है बेटा. वैल्यूज अगर कुछ आड़ी टेढ़ी हुई, इग्नोर द वैल्यू. फॉर एग्जाम्पल हियर द Kc is very less. Guys, Kc is very small. When Kc is very small means what? Kc is very small means product is very small and reactant are very large. That is, there is hardly any change in concentration of the reactant. Okay, guys. Therefore, you can consider here that X to be very small. So straight away, instead of all these value, what we should do? We should take simply it is going to be 0.1 x square upon N2. You can straight away take, yes, straight away take how much? X को ignore करो. X को ignore करो. This will become 0.482 upon 10. So it will become 0.0482. Yes, guys. डरना नहीं है. Whenever the question is big, हम घबरा जाते हैं. Whenever these data are big, हम घबरा जाते हैं. We need not to do that. बहुत थोड़ा सा कंसेप्ट लगाना है कि बस वैल्यू हाई है, वैल्यू लो है तो ये होगा, वैल्यू हाई है तो ये होगा. बहुत इजी है, थोड़ा सा सोचो. Okay, guys. Now this will become 0.0933. Is that clear? This value will be 2 into 10 raised to the power minus 37. Okay, guys. It might be, initially it might seem difficult, it might seem lengthy, it might seem डरावना, Okay, okay, but it is not so. You have to simply apply one thing over here. The value 10 raised to power minus 37, the value of Kc is so small. Therefore, a little bit of product must have been formed, or this moles of nitrogen and oxygen must be constant over there. There, the value of X must be very, very small. Is that clear? Is that clear, guys? Okay, okay, guys. This value of Kc is given this much, and guys, put the value of Kc over here and solve this entire equation for x. How much x we are getting, guys? How much x value is coming out to be 6.6 into 10 raised to the power minus 20. X will be 6.6 into 10 raised to the power minus 20. Now the fine, just put the value of x over here, though though the composition will be easily found out. Is that clear, guys? Is that clear? X is coming, so putting the value you will find the composition very very easily. Clear? So हमेशा concept देखना, question बहुत अच्छे से पढ़ना है, घबराना नहीं है. Okay, and it will happen only when you will have a practice of the question. You will have a practice of the question, guys. थ्योरी पढ़ के तुरंत क्वेश्चन की प्रैक्टिस करो. Trust me, you will start loving physical chemistry. That is only the mystery of physical chemistry, guys. Okay, okay, yes. Come on. The next question on the screen. Nitric oxide reacts with bromine and gives nitrosyl bromide as per the given reaction. Is that clear? When this many moles of NO and this much moles of bromine are mixed in a closed container at a constant temperature, this mole of NOBr is obtained at equilibrium. Very, very simple question. What you have to do? You have to find out, you have to calculate the equilibrium amount of nitric oxide and bromine. What you will do? What you will do, guys? Yes, let us see. Let us see. This is the reaction given, guys. Okay. Now, 0. Yes, guys, 0.0518 mole of NOBr is formed from what? It is formed from 0.0518. Yes, 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 mole of NO. Okay. Why? Because in this equation, guys, it is very clear. 2 mole of NO gives 2 mole of NOBr, or 1 mole of Br is forming 1 mole of Br, 2 is forming 2 mole of NOBr. Okay, this relation. So if it is 2, it is 2. Yani same mole, x mole of this will, x mole of NO will give x mole of NOBr. Or y mole of Br2 will give 2y mole of NOBr. Okay, okay. If this is how you will able to solve the question, straight away you are going to get the answer. Clear, guys? So how much mole of NOBr is formed? NOBr moles are, guys, 0.0518 mole. All done? All done, guys. So using this data, the mole of NOBr is going to be equal to, is going to be formed from same mole of NO. So the moles of NO will be 0.518. Is that clear? And mole of Br2 will be half of it, 0.518 by 2 mole. Are you getting this? This we have done, calculated from this data, from the balanced equation. Is that clear? So here balanced equation are very very important, isn't it, guys? All done. Now, guys, what is the concentration at equilibrium? Equilibrium amount of NO. How much at equilibrium amount of NO? Yes, yes, yes. It is given as 0.087 NO. All done. All done, guys. All done. So amount of NO is going to be how much? How much, guys? It will be at equilibrium. Let us write here. At equilibrium, guys, at equilibrium, NO amount will be equal to, yes, 0.087 minus from which? Because this much mole of NOBr is formed. Yes, NOBr, this much mole have been formed from this much mole of NO. Are you getting this? Are you getting this? So at equilibrium, how much moles of NO is left? 0.087 minus, it will be this one from here. This much mole of NO is reacted with O2 and formed NOBr. Okay, so the for left mole of NO, you have to subtract this. So it is going to be 0.518. How much it is coming out to be? 0.0352 mole. Is that clear? Is that clear, guys? Now amount of Br2 or moles of Br2 left is how much? Br2 initially was how much? This much are mixed now. So these are the initial moles, and this much mole have of NO and O2 are required for formation of NOBr. So how much moles of Br2 left? Guys, initial moles of Br2, this is 1.0437 minus guys, half of this one is coming out to be 0.0259 mole. So it has to be subtracted from this. This is going to be equal to 0.178 mole. 0.0178 mole. So the left moles of NO and Br2 are there, and that is there. Calculate the equilibrium amount of NO and Br2. Is that clear? So what we have done, from this balanced equation, we calculated the entire composition. It is very, very clear that 2 moles of NO is going to give 2 moles of NOBr. And the moles of NOBr so formed at equilibrium is 0.0518 mole of NOBr. Okay, so 2 moles of NOBr is forming from 2 mole of NO. Similarly, 0.0518 mole. Sorry guys, sorry. I'm going to take you to the previous question. Okay, 2 moles of NOBr is forming from 2 moles of NO. Similarly, 0.0518 mole of NOBr will be formed from 0.0518 mole of NO. And just half of the moles of Br2. Is that clear? So using that data, we have to find out the equilibrium composition. Okay, given moles minus the moles used for formation of NOBr. Is that clear? Is that clear? Let me take you to the next question, guys. Now the next question on the screen. At 450 kp is given 2 into 10 raised to the power 10 bar for the given reaction at equilibrium. This is the reaction. What is Kc at this temperature? Yes, all done? Clear? Let us study this. Temperature is given, Kp is given, guys. Very, very simple. We have done this question, this type of question before. Kp is equal to Kc into RT raised to the power delta Ng. And delta Ng is gaseous moles of product minus gaseous moles of reactant. Gaseous moles of product is 2 minus gaseous moles of reactant is 2 moles of SO2 and 1 mole of O2. That is 3. So here delta Ng is coming as -1. All clear, guys? Kp is given. So Kc is going to be Kp upon RT raised to the power delta Ng. Just keep on putting the value. Kp is 2 into 10 raised to the power 10. Done? Upon RT. Upon RT. R, how much R value will be? Yes, as we have discussed before. 0.0821 into T is how much, guys? Temperature is 450 Kelvin already given. Raised to the power -1. Clear, guys? Solve this. You are going to get the value as 7.48, 10 raised to the power 11. What is the unit of Kc, guys? The unit of Kc, I told you initially, mole per liter raised to the power delta Ng. And it is what? -1. So guys, the unit is going to be what? Yes, unit will be mole inverse liter. Mole inverse liter. It is very, very simple. Kc, the unit of Kc is going to be calculated this way. Mole per liter raised to the power delta Ng. And as delta Ng is -1, so unit will be predicted this way. I hope you really learned a lot. This is how you should practice it. Remember, the best way to study physical chemistry, read the theory, then the numerical. Thank you for watching it, guys. Those who have not subscribed the channel so far, do so. Do so, guys. And in order to have further notification, please press the bell icon. And if you have not liked the video, do so. If you have not shared the video, do so. And for taking the subscription, do apply this referral code of mine, SA10. Thank you for watching, guys. All the very best for your examination.